with Microsoft, and I do talk on policy for Microsoft. So welcome to Microsoft's Innovation and Policy Center. It is a place that we welcome discussions around the intersection of policy and technology. And we're very happy today to have the Internet Society here and the panelists here to discuss spectrum policy. It's a very ripe topic of conversation in DC, and for Microsoft, as well as for many companies, it's really an important piece of the puzzle. As folks have heard over the course of time, over the past 5 to 10 years, there's been a lot of varying visions about what the future holds, and there's been talk about 3 or 4 screens in the cloud. There's talk about always connected. There's talk about access to data whenever and wherever you are, and that happens really to the extent that spectrum is available. It is happening today, and the question is how robust that vision will be, and that vision really rests on the availability of spectrum. From Microsoft's perspective, we are supportive of both licensed and unlicensed spectrum. However, we believe that in order to, a piece of the puzzle or a piece of the solution in ensuring that sufficient spectrum is available is ensuring that there are technologies that can leverage dynamic sharing technologies or leverage dynamic sharing access. At the end of the day, when you think about those kinds of technologies, think about technologies such as the technologies that you see in the TV band, the databases, and leveraging databases to utilize spectrum that's going unused at the current time. Earlier this week, I had maybe not so much of the great fortune, but I was watching a news report, and they were talking about the internet, and the best iteration or description they could give of the internet. This is a news program, so I was hoping for a really nice, crisp, brief description, but it was essentially a blue background, tunnel-like graphic with ones and zeros. And I know our panelists will do a lot better than that. There are a lot of issues to talk about, a lot of proceedings that are happening at the FCC, and a lot of thoughts about what the future holds in terms of spectrum sharing. In addition to the kinds of things that we think about, the carriers are working hard on doing things like offloading smaller cells. So all of this will need to happen in order to deliver the solution. So we welcome the panelists, we welcome the Internet Society, and we welcome everyone in the audience, and look forward to a really robust and fruitful discussion of the issues.
Hi everybody, and thanks for coming. My name is David Vyorst. I'm the co-convener of the Washington, D.C. chapter of the Internet Society. How many of you are familiar with isoc, the Internet Society? It's not bad. isoc is a global organization dedicated to maintaining a free and open internet for the benefit of all people around the world. Our mission, our activities in the DC chapter aim to take that mission and bring it alive in Washington, D.C. because of the importance of D.C., not just as a center of government and a policy center, but because D.C. is also a tech hub and a communications hub. Many of us take an open internet and all the awesome stuff we do online for granted. But the future of an open internet is way too far from being a given. And we'll take work and we'll take participation by people who have an interest in it to make sure that it stays open. There's several things in the near future that will impact this. The use of unlicensed spectrum and what we do with spectrum, getting spectrum policy right, is one thing. The future of ICANN is far from certain, and there's a lot of other things. We urge everybody to get involved with our chapter. You can find us online at www.isoc-dc.org. You can speak to any of our chapter reps here. Would everybody involved with the chapter raise their hand? And we need support, we welcome contributions, we welcome institutional organizational partners, but more importantly, we welcome your participation. We have some great events coming up. Mike Nelson's going to tell you a little bit more about an event we're having 1 week from today in this very same room. We have monthly happy hours that will begin again in December. We have roundtable discussion breakfast, and we have some very substantial panel discussions. Please join us. Thank you.
I'm Mike Nelson. I'm a Principal Technology Policy Strategist here at Microsoft. I've been in the job for about 2 months, and I'm very happy to be able to help organize this event using Microsoft Space to showcase one of the most important debates for the future of the Internet. Just a quick commercial for next week. David mentioned that the Internet Society and Microsoft have organized a debrief on the Internet Governance Forum that was held last week in Bali, Indonesia. Some of you followed this day by day. It was webcast. Others probably are totally unaware of what happened in Bali, but it was a fascinating international discussion with about 1,500 people from almost 100 countries talking about wireless internet, online security, NSA surveillance, human rights in cyberspace, domain names, and a heck of a lot more. What we're going to do next week, same time, same place, is talk about what happened. About 10 of the people who were there are going to give their impressions, and most importantly, we're going to talk about where things go in the future. What's the next step? What are the next meetings we need to worry about? What are the hot issues that we need to organize around? I'm here today partly to say thank you for coming, but also to talk about the work of the Technology Policy Group at Microsoft. This facility is mostly run by the U.S. Government Affairs team for Microsoft, but several of us from other parts of the company also work here. I'm part of a group called the Technology Policy Group. Our mission is to figure out where technology is going to take us in 3 to 10 years, and then to work backwards to make sure we're taking appropriate steps to enable that connected future. One thing we're doing in this space is running demos on TV white space technology to look at how next generation wireless technology can support broadband wireless, and perhaps most importantly, the Internet of Things, or what I like to call the cloud of things. So we've done projects over the last 4 years in Southwestern Virginia, in Singapore, Switzerland, and now we have a big push in Africa. So the For Africa project, number 4, Africa, includes a lot of different initiatives, but our team is doing one that is connecting schools, clinics in Kenya, in Tanzania, and in South Africa. So for more details on all that, talk to me, or I can send you a URL outlining some of the very exciting new opportunities that we see with the TV white spaces technology. But let me now turn over the program to Afzal Bari. He is our moderator, and he's also a good friend. Prior to joining Microsoft in August, I spent a little over a year working for Bloomberg government, and Afzal sat right next to me because we were part of the technology policy team reporting on developments in technology policy. He's been tracking the wireless industry and wireless policy for several years, and I think he's the perfect moderator to introduce our panel and to get the discussion going. Afzal.
Good morning, everybody. So my first question is actually not, before I introduce the panel, it's not for the panel, it's just for everyone here. It's just as far as to level set, how many here are, consider themselves spectrum wonks or reading FCC filings and deep in the weeds? Okay, so it's actually, we have a mix, and we'll try to make sure that we tailor the questions and the presentations to that mix. But without further ado, let me go ahead and introduce our panelists. First, actually, so on the far left is Michael Calabrese with the New American Foundation. He's going to go up first, presenting what the Open Technology Institute's view of spectrum is, and immediately to his left is Charla Rath, and she's with Verizon. and she'll actually go last.
Put on in the middle.
We're going to switch this up a little bit. And then next to her is Preston Marshall, and he's with Google, and he's going to talk a little bit about the technology that they're working on and their view as well. Let's go ahead and get started. I think, Michael, you're going to jump up here.
Yeah, it's probably easier from there, so I can see slides and notes both. All right. Well, good morning, and thanks for including me in this this event. It's great to get directly involved with the Internet Society here. Thanks, David, and of course to Microsoft for hosting. So I believe everyone's familiar with the exploding demand for mobile apps and data. And this is likely to continue for quite some time. Smartphone penetration only surpassed 50% here in the US and in the UK early this year, and only about 22% of households have tablets. So we are less than halfway along the initial adoption curve. And yet, as you can see there, the growth rates are pretty staggering. So why mobile carriers can't meet this demand? So in that sense, the notion of a spectrum crunch is correct. Mobile carriers can no longer meet this demand simply by buying more exclusively licensed spectrum and deploying more carrier infrastructure. All the prime bands are assigned to someone, and as we just saw with the 2-year struggle to clear just 25 megahertz, as it turned out, I mean, this is at 1755 to 1850. It was all about 95 megahertz from the military and a dozen other federal agencies. And after 2 years and 5 working groups, it's looking like 25 megahertz, and that's far from a done deal. So the PCAS, the President's Council of Advisors on Science and Technology, as you'll see in a few minutes, part of the basis for what they came up with was that clearing spectrum for auction takes too long, is too expensive, and at best delays the inevitable transition to small cells and dynamic band sharing. In addition, if we want mobile market competition, we need more spectrum, not less. So the conventional wisdom in Washington is that spectrum is scarce. You know, here's it looks like an urban planning map. It's all been assigned. Much of it is already, in fact, shared between different users. But in reality, it's government licenses that are scarce. The spectrum bandwidth itself is abundant. So if you actually go out and measure it, even in the prime so-called beachfront spectrum below 3 gigahertz, less than 20% is actually in use right through the middle of a typical business day. We measured it years ago in downtown Washington over the White House. Here's some other measurements that Mark McHenry did for the National Science Foundation. Microsoft actually has a spectrum observatory on the roof that shows similar findings over long periods of time, and there's really cool stuff on the internet that you can see that they did with Dennis Roberson, who chairs the TAP, the FCC's Technology Advisory Committee, and he's at IIT. So the great disconnect is scarcity amidst abundance. And I guess what I'd like to talk about today is 2 parallel paths to bandwidth abundance. In the short run, we have Wi-Fi offload on unlicensed bands. And that is actually taking the load to a far greater degree than people, I think, realize. And then in the longer run, we've been advocating use it or share it. That is dynamic spectrum access to underutilized bands, beginning with federal bands, because the federal spectrum below 3.7 gigahertz, that prime spectrum, is the least occupied, even if, you know, the military and others say when we need it, we really, really need it. So, luckily for both carriers and consumers, Wi-Fi has been offloading a rapidly growing share of total mobile data traffic. The most encouraging contradiction, in fact, I think, in telecom policy today is the gap between claims of a looming spectrum crisis and the reality that consumers rely increasingly on a small amount of unlicensed spectrum to satisfy this exploding demand for video and other high bandwidth apps. Today, at most 2/3 of mobile device traffic travels over cellular networks in the US, a share that is likely to fall below 20% within a few years. The rest is transmitted a very short distance at low power over unlicensed spectrum and into a wireline network at home, at work, and an increasing proliferation of public spaces. The chart that you see up here is from the European, a study by the European Commission in August, a quite lengthy study, which is really worth reading. And they are projecting, based on using software on some thousands of mobile devices in Western Europe, that Wi-Fi offload may actually already be over 60%, and they project it will exceed 80% by 2016. So to truly understand how Wi-Fi and small cell offload can solve the spectrum crunch, at least in the short run, it's critical to distinguish between two very different types of mobile device use. First is truly mobile, which is on the go, what we typically think of, right? In the car, on the go. But much more commonly is nomadic use, at home, work, in a cafe, outdoors near a wire. Because anywhere you're near a wire, you can get offloaded without going that long distance through carrier spectrum and carrier infrastructure. Surveys show 2/3 of all mobile device use is at home or at work, and that only 10 to 15% of the time are users on the go or outside the sort of retail and public spaces that increasingly have Wi-Fi access. Wi-Fi and high-capacity wireline connections are becoming increasingly ubiquitous in all the places consumers most commonly use high-bandwidth apps, such as video streaming and video calling. Happily, video, which is driving mobile data demand, is also the most nomadic. Verizon actually has estimated that already a majority of its mobile data traffic is video. And what's interesting is that more than 85% of video is watched indoors on mobile devices. And since that's probably going to be 80% of the traffic, and 85% of it more watched indoors, it gives you a sense of the opportunity to take that mobile traffic off of the conventional cellular network. Already surveys show that 80% of consumers prefer to connect via Wi-Fi. This chart from Cisco's user surveys shows consumers clearly prefer Wi-Fi because of its lower cost, right? There's typically not data caps or tiered pricing, or to the extent there is, say over your wireline, has a much higher ceiling. Higher data rates, as long as you're close enough to the access point, and better performance in general. Wi-Fi is a windfall for mobile carriers as well. The Consumer Federation of America had a study a little over a year ago that estimated carrier costs would be $20 billion higher if they had to deploy additional cell sites and backhaul to carry all the data traffic currently offloaded by Wi-Fi in the US. In Europe, the European Commission study I mentioned estimated that in the 27 Eurozone countries, that savings is 35 billion euros today, and that will rise to 200 billion euros a year by 2016. In short, small cells and open spectrum can maximize spectrum reuse and distribute the cost of backhaul and innovation to the edges of the network. Although the overwhelming majority of Wi-Fi offload continues to be self-provision at home, at work, at Starbucks, in Europe and Asia, another disruptive trend is emerging. Wi-Fi networks are being built out by wireline ISPs and are blanketing high-demand urban and suburban areas with literally millions of hotspots, creating clouds of connectivity. In the UK, British Telecom, the Ma Bell of England, strictly a wireline provider, has already turned 5 million of its wireline customers into public hotspots. Opening your connection to all other BT subscribers is the default option. In France, Free Mobile has turned 4 million of its wireline parent subscribers into public hotspots. This has allowed Free to undercut the pricing of the dominant mobile carriers in France. And in the US, the 5-company cable Wi-Fi consortium has already deployed more than 200,000 hotspots, mostly outdoors and in congested areas such as retail districts and sporting venues. We had an event, there was an event last week at NCTA that focused quite a bit on that. Comcast announced this summer it is effectively adopting the approach of BT and the phone consortium, which is BT and the other carriers in Europe that have 10 million hotspots. And with 20 million subscribers, it could easily blanket its service areas with a cloud of Wi-Fi connectivity. Today, Wi-Fi depends mostly on a dedicated but limited band at 2.4 gigahertz. That's where 85 to 90% of the Wi-Fi traffic is running. But that's becoming congested. Over the longer term, opportunistic sharing of other underutilized bands can unlock vast amounts of unused bandwidth. For years, we've been advocating a use it or share it approach. The notion, as it says up there, is licenses are for exclusive use, not non-use. Under the Communications Act, unused capacity remains available to the public. So the basic idea is to identify bands, one after the other, that are the most underutilized and useful for opportunistic sharing on a secondary basis. And that's essentially the approach that the President's Council took in its report last year. So the PCAST advised President Obama to release an executive order stating that the government's policy is to share underutilized federal spectrum. Now the report focused only on federal bands and didn't look at actually commercial. So that is actually an executive memorandum, was released in June as a bookend to the memorandum a couple years back in 2010, I believe, June 2010, which embraced the national broadband's goal of 500 megahertz more of licensed and shared spectrum. And then the PCAST also, another headline recommendation was to identify a 1,000 megahertz federal super highway for sharing, starting with the 3550 to 3700 megahertz band, and an FCC rulemaking opened on that in last December, which I'll say just a little bit more about in a minute. So the basic, I think Preston is going to go in a little more detail into the PCAST recommendations, but I'll just skim over the fact that a key element is the 3-tier hierarchy of access. In other words, there's a presumption that until such time as federal users can actually clear off a band, which may be in 5 years, 10 years, maybe never, that they would be protected from harmful interference and even allowed to evolve their systems. Then there would be secondary access, what the FCC in its 3550 proceeding calls priority access, where users can pay for protection and get, on a small cell basis primarily, can get use where they only have to worry about protecting the federal primaries. And then as a kind of an underlay, you might say, across the whole band would be general authorized access. In other words, to use it opportunistically using dynamic spectrum techniques, particularly the spectrum access system, which the PCAST envisions as a more sophisticated version of the TV band's database, which governs unlicensed access to the vacant TV channels. So in other words, in the TV white space, so-called TV white space proceeding, if you want to make unlicensed use of an empty TV channel, and actually a minority of the channels are available for unlicensed use in order to protect broadcasters, but the ones that are open, you need to have GPS, and you need to check your position against this online database and get a list of available channels where you are. So the channels, the frequencies available to you here in downtown DC, of course, are going to be very different than the ones available, for example, if you're out in West Virginia or in Gaithersburg even. So the spectrum access system, I know something that the press has been spending a lot of time figuring out how this will work. So the advantages of building on a TV bands database are quite substantial. I think it's very unappreciated in terms of the TV bands database, for example, that there's no permanent assignments and no stranded users. That's why when the FCC has its incentive auctions for more TV spectrum soon, there'll be channels that white space devices are using, and then suddenly that'll be taken out of the database and those devices just will move to use other channels. Hopefully, there'll be other channels to use. So you basically, it leaves the commission with the flexibility to reallocate the spectrum later. Access to the bands can be subject to unique operating conditions which protect the federal primaries. Preemption, shutdown, and priority access can be part of that. And so any tragedy of the commons can also be avoided, because there's also always been this thought, oh my God, what if unlicensed devices or opportunistic access devices flood a band and nothing's working, right? Tragedy of the commons, overgrazing. But that doesn't need to be the case when you have a database that is monitoring the usage and can regulate, and maybe you can't be the number 100 device, at the corner of Connecticut and K. So finally, I'm going to just mention just a minute here on this 3550 proceeding because it's active. As I mentioned, the PCAST said there was a potential spectrum superhighway that NTIA had identified in its fast-track bands between 2700 and 3650, 950 contiguous megahertz that are almost all federal and operations like radar that could potentially be shared. So in terms of what's next for white space in its broader sense, we currently have the 3.5 gigahertz NPRM, what the FCC is describing as, or has proposed as, a citizens broadband service. And these quotes are from the NPRM. The FCC modeled the proposal on the spectrum access framework proposed by PCAST, three-tiered licensing and interference protection based on protecting federal primaries. In this case, it's mainly naval radar, Navy radar, mostly offshore on ships. Priority access, they proposed actually a very constrained view of priority access being indoor for mission-critical uses, like in hospitals, public safety, and so on. That's likely to be expanded quite a bit. And then general authorized access, which is opportunistic, but must register with the spectrum access system. Think of it as being very much like unlicensed access to the TV white space channels. And then finally, the spectrum access system will control that. And the other way we're expanding on license right now is the pending 5 gigahertz proceeding, which the bottom line is the bottom line. It proposes up to 775 contiguous megahertz for indoor and outdoor use, which will support very wide, high-capacity channels for the 802.11ac standard, which is being called gigabit Wi-Fi. And that's it.
Thank you, Michael. So before we jump to press, let me just ask one question about this, and we'll open it up for audience questions after all the panelists have had a chance to speak. But so you've talked about a lot of different areas, a lot of different NPRMs, a lot of different proposals. Let's focus on Wi-Fi offload, right? So could you just, in 1.5 minutes, say, what needs to happen for your proposal to actually become a reality, and are there any other public policy actions that need to be in play for Wi-Fi offload and to take off the way that you want?
Yeah, I think primarily to make more spectrum available for that, make small cell and unlicensed, band sharing, just more prevalent and at a variety of propagation characteristics. That's why it's very important. I didn't go into it, but also the TV white space, the unlicensed access to the TV band, despite the incentive auctions, we need to make sure that there's at least a minimum amount of that spectrum available in every market, because that's low band, wide area, high penetration spectrum, which is not for capacity, it's for coverage. But then for capacity, making sure that 3550 proceeding, the Citizens Broadband Service, making sure that there's opportunistic access available for edge network devices like consumer routers and so on. As I said, most Wi-Fi, 95% is self-provisioned, and so consumers should be able to get routers that build opportunistic access through 3550 in, and then 5 gigahertz also, making sure that we don't have that chopped up the way it is now, contiguous for much wider channels, much higher capacity.
Okay. So if I can encapsulate that, it's taking future spectrum that might otherwise be licensed or auctioned and allocating some of that for unlicensed use, and in a nutshell, right?
Yeah, although relatively little of the spectrum I just mentioned would be auctioned.
Okay.
It's not even above 3 gigahertz, it's typically not even in demand by carriers for the conventional business model. So I think you'll be hearing maybe from the other speakers, there's pretty good consensus on making the 3550 band, for example, available for more shared small cell use on a very granular basis.
Okay, great. Preston?
Okay. You up here or there?
My name is Preston Marshall. I'm from Google, just recently joined. And I'm going to talk about the PCAST recommendations and where they lead in terms of creating wireless abundance. And the key here is really spectrum sharing. So let's think about wireless and what our goals are. Because if we think about a wireless strategy, the strategy shouldn't be driven by just more wireless. It should be driven by an objective. And if we don't meet that objective, the strategy is not good. Qualcomm gives us one. Its bandwidth will double every year. 10 years is 1,000 times, roughly. So if you took every bit of spectrum and dedicated it to carrier wireless and macro cells, you get about 5 times more. So it's not a strategy. So when PCAST came out, it said we need to do something different, and it's much more radical, and it's not going to be evolutionary. And it was that clearing spectrum, even if we could get this 5 times, doesn't really get there. And so we have to really think about strategies that are built around aggressive spectrum reuse. And the federal bands, because they weren't occupied very heavily, as Mike mentioned, became a good candidate for that. And therefore, we should be not thinking about what spectrum is suitable for large macro cells, which I think is in one of Carla's briefings, but we should think about a different mode of operation that will increasingly dominate wireless provisioning, as Mike mentioned, and that's the low power short range systems. So it was mentioned to me that most people here are internet people, not spectrum walks. So a lot of what I'm going to say is like, duh. Why wouldn't it be like that? We have to understand that wireless regulation was put together after the Titanic sunk. And these people were the first victims of bad spectrum management because there was a lot of interference and no one knew that the ship was sinking. And that led, can you believe it, Congress passed within a year the first wireless licensing bills and all. And we're really managing spectrum today the same way. And so a lot of what we're going to talk about, if you're an internet person, you think about packets, you think we dump circuit switched a long time, but all the concepts we're going to talk about here really evolved in many, many generations ago. So, Mike mentioned this was going to be a debate. It was certainly a strong debate a year ago when PCAST came out. I think the process of forums like this, at least in terms of immediate action, we're seeing a large convergence and consensus in the community. But these are various cellular industry association press releases. And as Mike mentioned, in PCAST, he said that's really not the problem. The problem is that we've built out our cellular networks. You no longer go and get that map to go read, is your house underneath the red or blue coverage from your carrier? We've achieved coverage. And now we're thinking about how do we get capacity, and the problem is fundamentally different. Low-hanging fruit for relocation was already taken. Each time we go to get spectrum, it gets harder. I watched the telephone call for CSMAC for 1755, and there's 100 people in this phone call, and they're fighting over 25 megahertz. Used to be you could wrestle 100 megahertz out of the government. It's getting increasingly hard to do that. And if you think about there is a shortfall, spectrum crunch, spectrum crisis, shortage, the shortage really isn't in spectrum. Spectrum can't solve the problem. The shortage is in infrastructure. The more infrastructure we have, the more wireless bandwidth. Whether it's a Wi-Fi access point or a macro cell sector, we get about 100 megahertz out of it. So if you want more bandwidth, the strategy is how do I get more infrastructure deployed to create more access? So let's think about this. Coverage versus capacity. People thought of low frequencies as being beachfront. I think of coverage, low frequency is the last thing I want. So think about the difference between building coverage, long range, high power, lower frequency, and capacity. Short range, because I want to have a lot of these grouped next to each other. Low power, higher frequencies, built where people are, whereas we build towers where people aren't, because the neighbors complain if Verizon comes in and puts one of those towers there. And 3 or 4 years ago, before the iPhone, this was theoretic conjecture. But now it's reality. As Mike showed the statistics. In fact, wireless short-range systems are not offload, they're not adjuncts, they're becoming the primary means if we think about this as an integrated wireless capacity. So now let's move on to the PCASH report. I think it should be great reading. They don't score it on Amazon, but I think it's really driven the dialogue in this field. When it came out, there was massive objections to it, but I think there's convergence and a lot of those ideas are beneficial to everybody in the community. Let's think a bit about it. So here's the numbers. If you're an engineer and your goal is to get 1,000 times more bandwidth, and I won't give any more spectrum, there's nothing much left in the air interface that's very well designed. And so the way we're going to get there is by shortening the range. That's the only engineering solution open to us. If we go from a click, roughly, say, for its current macro cell, and we get somewhere down around 33 meters, we get our 1,000 times more. 33 meters is a pretty large range. That's larger than most offices. That's larger than most apartments. So if we start to think about wireless capacity in a very retail provisioning architecture, we get our 1,000 times. There is a way to solve the bandwidth shortfall. And what it means is exploiting all the copper, the fiber, and all that is already around us instead of shipping cellular signals a kilometer to us. So what did PCASH recommend? First of all, let's not touch the civil sector. That would be like the third rail. Leave that spectrum as it is. Let's use the federal spectrum, which is relatively loosely, poorly occupied. Let's use that as a starting point to understand spectrum sharing. Low power technologies are practical. NTIA said we can't share the 3.55 band with people like Verizon because they're really high power. There'll be all these problems. But if you think about the same problem, if you think about it as an offload, all of a sudden that became much more practical. Roughly a gigahertz, as Mike mentioned. And then this second innovative idea, which the world should all applaud us for, which was, let's put multiple classes of users in the same band. We've never done that before. Let's not think of this band as unlicensed or carrier exclusive. Let's think about it as something where both exist and they coexist. And both the equipment and the usage marketplace competes. We'll talk a little bit about the implication of that. Let's also make licensing short term. Today, essentially, when you buy a spectrum license, you're buying it for our perpetuity. Yes, it comes up for renewal, but there is a presumption of renewal. I'm told that under FASB, you don't even depreciate spectrum, which certainly constitutes an assumption that it's a forever purchase, which means it's billions of dollars. We don't see a lot of venture investment in things in the wireless space. Because can you imagine going to a venture capitalist and saying, I want to put $3 or $4 billion down, buy a bunch of spectrum. It will take the government an average of 8.2 years to clear that out and make it available, and then we can try the business plan out and see if it works. Not going to happen. So let's find ways where people can get spectrum in a retail manner, a short purchase, leasing it, little mini auctions. Eric Schmidt was a co-chair of this. So very strongly influenced by the idea of things like AdWords, where Google does a microtransaction for every search request. And then let's also recognize that right now we have no one who looks at spectrum as a national asset. We have the DoD and the federal users here. We have the FCC with its clientele. And let's understand at least strategic aspects of spectrum at the White House level. So, 3 tiers. Another innovation in PCAST. Let's separate exclusivity from protection. We did, after the Titanic sunk, the only way we could protect people was to say, this is the only thing you can do in this band, and these are the only people who can do it. But we don't have to do that anymore. Our goal was never exclusivity. Our goal was to protect communications. So let's give people the right to be protected, but let's not give them the right to exclude other people when they're not using the spectrum. I think Mike's been very successful at pushing his use it or share it principle, and I think this is the instantiation of that. Therefore, all spectrum gets used by somebody. So you can sort of think of everything is unlicensed, and then people come in by some mechanism and acquire the right to be protected. So think beyond it. What does that do to our equipment ecosystem? It means that I can now think about equipment, the exact same equipment that could be unlicensed or licensed. I could buy an LTE base station, and if I could put the infrastructure, I could use that as instead of my home Wi-Fi. Verizon could decide it really wants good Wi-Fi service and could buy protection for it. These two become independent. I personally believe LTE has a lot of advantages for premises communications. Today is unaffordable. We sell hundreds of millions of dollars of Wi-Fi base stations. We sell very little LTE base stations. But if we had a consumer market for LTE quality equipment, then we could bring the cost of these two systems down. We could have a more seamless Wi-Fi experience. These decisions become market-based rather than partitioned by regulators. Which is the right technology? No idea, but we'll find out because they'll both compete in the same market in the same spectrum. So there are a lot of arguments against this when this first came out. For about 6 months of my life, I spent going around to various industry forums kind of arguing with the cellular industry. One of the points was industry will not invest unless it's got exclusive access to the spectrum. The very same people who are sitting arguing this were sitting doing press releases about their investment in Wi-Fi offload. Enough said. It depends on technology that's not there. We're talking database and clouds. Very clearly, we've got a successful experiment with TV white space. And we've developed the technology so we can move that out. And the wireless industry needs exclusive access to all possible protection. I think we have to think that wireless is no longer the carrier industry. Wireless is now an integration of a lot of technologies delivered a lot of different ways. And so what we want is a system that balances those usages to create wireless. It's not hobbyists versus serious people. And so having an architecture which allows both to coexist and let the market decide the balance for those really is a more appropriate way to think about an overall national wireless architecture. Shared access. So it's advantages. I now have LTE available to potentially a lot of consumers. The security features, the authentication features, the quality of service. We have high volume of unlicensed devices actually benefits the carriers because if consumers adopt LTE base stations, then we develop an ecosystem in those components that matches the cost points of wireless. And whatever it is, whatever technologies emerge, we have an opportunity for all new kinds of players to get into the game. You can have community LTE. You can have private LTE networks, for example, machine-to-machine world, which wants protection but can't really afford the cost. You can deploy private LTE. High quality of service Wi-Fi networks, premises-based wholesale LTE. A whole lot of business options open up in this model that cannot exist in today's partitioning of totally unlicensed and totally exclusive. So just to go through a little bit of the history, Mike mentioned the debate. This is sort of the history of the debate. PCAST put this out, by and large. A lot of support from the different aspects of the administration, including the National Economic Council. FCC issued almost in parallel the NPRM for 3.55 gigahertz. Severe resistance from the cellular industry. I think now that resistance is starting to change. The House had a hearing. I was actually the representative for the report. FCC's NPRM presidential memorandum came out, basically mandating the core features of the PCAST approach. And sort of to show how this debate is converging, AT&T and Google have a letter of support for spectrum sharing, at least in the 355 band, supporting the idea of 3 tiers with broad eligibility into those tiers, the spectrum access database, the small cell exclusion, protecting incumbents only, that is, the government shouldn't protect the small cell, let us worry about how to protect it, you just worry about your system. and then the lightweight auctions. One of the principles of PCAS was you shouldn't just auction spectrum off unless you know people want it. So everybody comes into the band. If you have a conflict between users and they want to bid against each other, they so do it. But you're doing an auction on demand. You're not just going to go say, let's split up the country and then decide what we do later. They only arise when you need to have mutual exclusivity. So it's sort of more like a derivative business than carving up census districts. So this is sort of where we stand on this. There'll be another version of the 355 NPRM. It's really the first step. But don't think of the 355 as the objective for this. The objective for this is to go and move through eventually a gigahertz of spectrum with a broad class of properties where 355 is the easiest, not easy, but easiest to go and converge. And where that policy is successful, it can then move into other bands and other properties. Right?
Thank you, Preston. And in the interest of time, I'll ask you questions later when I do the panel, and we'll let Charla tell the audience why you're wrong and Michael's wrong.
Somebody pull up my, I just have a
Somebody's great.
So, despite what you just said, I am not going to argue with these guys. I'll just talk about something completely different. No, seriously, I thought about, as you were both talking, it was intriguing to me because I've probably been on panels with both of you fairly frequently over the last 10 years. And I think the conversation has evolved in what I think is a very good way. What I'd actually like to talk about is what I thought was, in fact, the subject, which is 2020. How do we know, is there going to be a spectrum crisis? Where will we be, and how do we deal with that? And I was reminded, you and I were on a panel 3 years ago in which Dale Hatfield asked us a very similar question, in fact, using the same date, so 10 years out, 2020. 3 years ago, I don't think we would have guessed where we would have been here. And the idea that we were talking 3 years ago about where we would be 10 years ago, 10 years from then, is just kind of mind-boggling to me. So one of the things that I actually always like to do in an audience like this, and I'm going to guess that given who you are, you're all smartphone users, and in fact I can see several of you are smartphone users right now. Not a lot of feature phone users, I'm going to guess, in this crowd. I actually do still have some family members who are feature phone users, and I can't quite figure it out, but that's fine. Quiz. How many of you use it, send and receive text messages? Access the internet. Send a photo or video. Send or receive email. Download an app. Access a social networking site. Got it? All of it. I mean, all of those numbers, they range from, 60% to nearly 100% of how we use our phones today. 7 years ago, so think forward, that's what we're being asked to do, is tell you what spectrum we need and how we need to use it in 7 years. 7 years ago, you guys were basically doing almost none of that on the feature phone that you were using. I had a BlackBerry that I used to access the internet on, and let me tell you, it was not an easy thing to do. But it did save me one time that everybody was amazed that I was able to get a cab out in the middle of western New Jersey when there were I was fine to get online. But you just didn't do what we do now. So for us to sit up here and say we know where we're going to be in 2020, and therefore we know how this should evolve, is probably a fool's errand. But that said, my view is what we need to be doing is all of the above. Basically the things that Preston has been talking about, the things that Michael's been talking about, and then some of the things that I'm going to be talking about. Because we really don't have a choice anymore to go after exclusive use spectrum. And by the way, I always want to make sure people realize that, yes, we have a very similar situation to where we were in 1912, more than 100 years ago in terms of block allocation for some exclusive use. But what the commission did with the help of Congress about 20 years ago is they said, this guy, Ronald Coase, who won a Nobel Prize for doing some very important work in terms of how to get spectrum markets to look a little bit more like, the markets that we deal with every day for a lot of the other inputs that we have. What they realized is they needed to actually have what is called flexible use. And if you have flexible use in an exclusive license with very active secondary markets, which is what the Commission designed over the last 20 years, you will get fairly intense use of spectrum. And in fact, I would argue that most of the places where you want extra spectrum, we're already using our spectrum fairly intensively, and it's because of several things. One is you do actually have to put down money and pay for it. So there's that. You also have to build it out where you're going to be giving it back. You also get to choose how you're going to use this spectrum. For example, when we bought 700 megahertz spectrum, in which we built out our LTE network, we bought that in 2007. I'm liking this, the symmetry with 7. 7 years before that, in 2000, we were actually thinking that that spectrum might be used for 3G. We didn't think it would be used for 4G. Well, in some countries, the government would tell you that that's who you would use it for. That's what you would use it for. In this country, the government doesn't. They have a set of technical rules. You have to follow the technical rules. The use rules are very, very broadly defined. And you basically, so if we wanted to actually, if there was a business case for it, wanted to just operate a Wi-Fi network everywhere on our, purchased spectrum, I'd have to double check with our engineers, but I'm pretty sure we could, because it would probably operate under all of the, the same sorts of terms and conditions that we have under our licenses. That's, we didn't pay billions of dollars to do that kind of thing. We operate macro networks. But one of the things that Preston just said that is very true is we are also, the business case we have is also evolving. We recognize that, if Qualcomm is right, and we have 1,000 times increase in the need for spectrum over the next 10 years, a macro cell network isn't going to cut it. We are, I completely agree that it is very difficult to clear spectrum. It's not that it was easy 10 years ago. It wasn't easy, let me tell you, it wasn't. But it was probably a little bit easier than it will be in the future, just because of the way usage has gone up. One of the things we're all looking at is network densification. The idea that you take a small cell, which Qualcomm will tell you is not much bigger than this, and you just you decrease the power and you increase the number of small cells. You also do add to that sort of novel approaches to auctioning, because you're not talking about where we were 10, 15 years ago, where you needed to actually get national coverage. You needed large large areas to purchase. So things are changing, and you've seen, as you mentioned, Google and AT&T came in very much in agreement on several principles with respect to the 3.5 spectrum, as did we. We didn't come in with you guys, but if you look at our filings, we're actually almost in the same place. And I think there's just a lot of agreement on the fact that this is valuable spectrum, that there are incumbent users, and there is a way that we need to share with the incumbents. I'm going to go back to that in a second, but one thing that I thought it would be useful to talk about is also something that I think both of you sort of touched on, which is incentive auctions. And this ties into just an overall, I am basically a policy wonk, and this has been something that I have actually had on my table for years, about getting more spectrum. If you are going to have exclusive use for some spectrum, you need to make sure that it is flexible exclusive use. So in fact, what incentive auctions are about is taking a use, and what's going on right now is we're all talking about the broadcast incentive auction, so we'll use that as an example. A use that may or may not actually have the sort of long-term value that, say, a more flexible use, mobile broadband would be one example, but it doesn't have to be mobile broadband. So what the Commission said is, what we'd like to do is offer up a way to say, broadcasters, if your time is over and it's time for you to move on, maybe what we should do, instead of trying to go after your licenses and do what we did in the DTV transition, which we just forced you to go off, maybe we'll say, why don't you come to the table and offer it, if it offers at a good enough price that we're able to put together a band plan and then resell it, then so be it. We've actually used the market to allow this to take place. Now, what we don't talk about is that the commission was not only given permission to do this for a broadcast TV auction, they were given permission to do this with any number of bands. And I would argue that for a lot of the things that you're talking about, Preston, there are bands that are being used commercially that the better thing to do would be just to get them out there for flexible use rather than to try and share. Because if, essentially, to continue a use that is inefficient and ineffective is just, from my point of view, an economic point of view, just doesn't make any sense. So the commission has this, they now have this tool in their toolbox. It will be a very complicated auction. We're probably not going to spend any time talking about that. But you know, I have firmly believed that anything worth doing is going to be hard. And if you were where I was 20 years ago talking about the first set of auctions that nobody even thinks about anymore, we just hold them and they just move on, everybody was saying the same thing. Oh my gosh, you know, can the commission actually conduct this auction? This is so hard. It's never been done on this level, this scale for a government good before. Well, 20 years later, we don't even think about it. I think, you know, the commission is in a good position to hold incentive auctions and make them work. And they'll work for broadcast, and then what we'll see is a series of them. It's sort of, you just need to clear the underbrush, which then pushes me over to the government side. While, you know, we actually, you know, I'm not sure you noticed this. I mean, you and I had a lot of private conversations about it, but we didn't publicly come out and say we didn't think the PCAST was, you know, a good thing. We just basically said, well, this is interesting. We think there are a lot of interesting ideas. Yeah, I know who you were talking about, but I just wanted to make clear we weren't one of the ones that said anything, you know, negative about it. We just felt like there were a lot of efforts going on right now that the government needed to be focused on, which was clearing, you know, government spectrum. To the extent I have a concern about PCAST, I think it assumes that it's okay to have an efficient use of spectrum. And I know you probably disagree with me, but that's where
First question.
that's where I'm going to show you. This is what we're supposed to be sharing with the federal government users. Now, that's all naval radar that, you know, to look at this map, you'd think it's on 24/7, 365 days a year, covering 60% of the population of the United States around every coastline that we have. That's great. So, okay, I'll go, you know, you know, it looks like Chicago's fine, which is a big market. That's good. Detroit, Kansas City, you know, so there are some big markets, you know, 40% of the population. So I just want to say that when you're sharing with government, this is a lot of what you get from government. Now, we are working this process. All of us are working within the confines of the 3.5 to say, you know, there might be a better way to share, particularly because this was based on macro cells, and if you do small cells, it'll be a different story. And I don't want to suggest that government doesn't have legitimate missions, but I do say from experience, having worked this process for a number of years, on both sides, by the way, that it's very hard to move the government in a particular way because they do not have the same sort of commercial incentives that we do to use spectrum efficiently and to actually, it just is so. I mean, you can't expect the government to do that. And their missions are important, but what I think needs to come, and maybe there needs to be a PCAST-like report on this, and in fact, I think something is going to be coming out of the federal government, you know, hopefully in December, that talks about market-based incentives for federal government use. Because I think that is a critical component of, you know, if we are really going to get enough spectrum to meet all the demands that we all seem to think that they're going to be in every way, you know, wireless, unlicensed, licensed, exclusive use, maybe a lot of shared, we're absolutely going to have to look to, you know, to providing additional incentives for the federal government to clear spectrum, move, use, you know, to use the money that they get from auctions, perhaps to use, you know, to buy, you know, better equipment. It's a very difficult problem, but it's not an intractable problem. And, you know, again, getting to it's too hard to move them. I firmly believe that if we roll up our sleeves and we put our minds together, they're great minds, you know, economists, technologists, there is a way for us to actually, you know, move the government toward more efficient use. So essentially that was what I was going to say. So I'm sure there are some notes I have on here that I didn't mention, but I'll turn it back over to you.
Okay, great.
That's fine.
Okay. Just to be fair. Okay. So let me just kick things off. Do either of you have comments that you wanted to jump in with, or?
I think the idea of markets is right, but the comment Charla made was that PCAS wasn't really market friendly. And I think actually it is a next generation of markets. I think what it does is that markets shouldn't be a one-time, that they are recurrent, that they are short-term, that it's not that you were the guy who had the most $1 billion 30 years ago, but it's a continuing one that makes not only do you have to be right once, but that you have to continually have the best market solution. I think PCAS was extremely market-oriented, and it actually then allowed the government to participate in that by creating a revenue stream that didn't flow into the Spectrum Relocation Trust Fund that could actually create the marginal benefit of federal relocation. Mm-hmm. So the idea was, if the federal government can see Spectrum selling for X amount of money, then they can take that money and turn it around and use it as O&M. The problem is Spectrum Relocation Trust Fund doesn't match well the way the government budgets. And so actually we tried to bring the government as a player into this so that it saw a marginal benefit, which you really couldn't see today. And so I think it's really market friendly. What it was is a very dynamic market as compared to, if you compare it sort of as, what we do now is like you buy a page in the New York Times for the next 10 years compared to Google AdWords, where you're buying it very dynamically, situationally. I would agree with you on your comment that there's a lot more low-hanging fruit. I think the problem we have is we still don't have the ability to build very broadband cell phones. And so part of the reason why PCAS didn't go there was you still have to have national bands. We didn't think you have to have national, like carrier owns this frequency and that frequency. Like when you buy a cell phone, you get this list of what frequencies are on each one. But at least there had to be national commonality. So buying up odd licenses all over the country, unless you could reband them, didn't look like you got there. So therefore 355 and the federal bands were at least contiguous, adjacent, and they were all nationwide. But I think everything you said there is true. But I just think we're one generation of technology away from being able to exploit it.
So in the interest of time, we have about 15 minutes left, right? So let me go ahead and take audience questions, and I'll jump in with additional questions if needed. Yeah. We have the first one here. And so, you could just introduce
Jim
yourself.
Snyder from isoc. A comment and then a question. The comment is to Charla. What the spectrum auctions are about. In addition to clearing the underbrush.
Could we take one of those mobile mics?
Okay.
That's right.
We're mobile now.
We can help you with your engineering.
I had an
Yeah. Jim Snyder to Charla. In addition to clearing the underbrush, a major aspect of what spectrum auctions, incentive auctions are about are a vast giveaway of public assets in such a complex and obscure way that the FCC, politicians who are behind it, can avoid any political accountability. So that's a different take, not part of the public discussion. But that's my question. The question I want to ask is addressed to Preston and the moderator. And that is, as both of you know, especially Preston, New America had a strong commons and high-powered view of unlicensed a decade ago. And then Google and Microsoft, beginning in the mid-2000s, started providing major in-kind contributions to America, as symbolized by Eric Schmidt taking over as the chairman of the New America Foundation. No, because you're the one who pays the bills. Google, I know you're new. So the question is, that has shifted in the last few years to cash contributions. So, for example, Eric Schmidt pays personally about $1 million a year or more. And on New America's website, Google is up to $1 million a year, and Microsoft up to $250,000 a year. And the question is, do you know what percentage of that goes to OTI, and specifically, Mike, I believe he has this program on his own, goes to Mike and OTI. Now, in addition, Google also used to provide, I don't know about Microsoft, daily consulting fees. I was one of the beneficiaries at $2,000 a day. I don't know if you're still doing that now that you're giving cash contributions. But could you just articulate Google's and Microsoft's relationships with New America, specifically Mike and OTI in terms of financial contributions? And if you know what percentage of their funding actually comes from...
I have a very short
answer to that. No idea.
Okay, and I have a short answer as well. So Mike Nelson introduced me earlier, so I'm actually not with Microsoft, I'm with her government. So we're just looking at how government policies impact the markets and impact companies.
So you don't know?
So I would have no idea about
A quick comment that, I thought Jim knew this because Jim worked at New America, and he asked a similar question last week.
I didn't get the answers, I figured I'd ask
Yeah,
them, that's why.
and actually, I wish that Eric Schmidt's the chairman of our board. I wish that his annual contribution went towards my work. Unfortunately, it's earmarked for our fellows program.
Yeah, the Google one.
Some of our fellows write about technology, but I think Eric's been giving like I said, on the order of $1 million a year for the fellows program.
Okay, Google also provides.
And then Google's one of like 8 companies that makes a contribution to our OTI, but I think corporate contributions are less than 10% of the total. It's now the majority is government. It's always been heavily foundation, and we get a bunch of really relatively small company contributions.
And let's
Not
go to
unusual.
some of the other questions as well. Yeah, that's fine. I'll go ahead over here. Yeah.
Trey Hammery with Hogan Levels. Great presentations, really appreciate it. I wonder, and I'm not sure whether this is Preston or Charla, in fact, maybe all of you would have a comment on it. There does seem to be a little bit of an issue of a zoning problem. If everything is completely flexible, or if the use is really determined by these micro auctions, how do you develop that ecosystem to really reach critical mass, to have enough devices to actually be economically deployed and supported? Along the same lines, for instance, if there's not some spectrum reserved for radio astronomy or backhaul or macro cell type deployments, it's not the case that it's all fully shareable. There are limits to how much power you can put in a band and how sensitive the receivers can be. So what role does that kind of zoning function, if you will, play within the context of a freely shared environment as envisioned by the PCAST report and other sort of models?
I think you probably have different answers on this.
Right.
So one of the arguments PCAST has is we did zoning type things, high powered, low powered, poor receiver, good power, because the regulators had to manage coexistence in years and years ahead of equipment being built. And PCAST's argument is we can now do that dynamically. And Tuesday, in fact, at the NTIA forum, we're going to have a demo of how we dynamically manage coexistence with C-band receivers based on the outer band emissions of different kinds of devices. So these were things before the regulators had to pick and say, this is what we think is in the band, and therefore these are the rules. I think the PCAST argument is we can make these coexist so long as there is transparency in what they need, and that they pay the consequences of their externalities, and thusly the exclusive. So if you have lousy equipment, you pay more. So we get the market driving equipment improvement rather than the regulators trying to drive it on a decade schedule. So I think it believes that coexistence does not necessarily require the kind of usages or controls. I think Verizon's totally correct. I think opening up to use had a lot of advantages, and that worked in exclusive license. Now we want to have that same flexibility in these non-exclusive licenses, and we think that's technically possible if you have transparency of equipment.
So, Preston, I'm curious, do you think that high power uses can be neighboring to, share with low power uses? Or how would that work?
Technically, I think the argument is that policy-wise, people saw an advantage in having this be a very dense band.
Yeah.
But from the electrical engineering point of view, I think the belief is, yes, you could make them totally compatible. You may not like the outcome, but it's not, that's a policy problem, not a technology.
Yeah, well, and it's interesting. I'm not an engineer, but I do know that I tend to actually be much more on the flexible use side, and every time I sit down with my engineers, I make them very nervous because of this issue of high power, low power, and as you mentioned, receivers. That's a subject for a whole other day. Talking about receiver standards.
But Preston, you mentioned you might not like the outcome. 30 seconds or less. Why?
Well, I mean, the outcome might be that you only get a small number of users in the band. But I think the argument was that
Which
that's
we
a
would like
policy
that
decision.
And probably our 100 million customers would not like that.
So the policy ought to say the kind of usage you want. But from the point of view of electromagnetic compatibility, we
Yeah.
believe that the approach in PCAS allows you the flexibility to do that without having to say everybody looks like this.
We have a question.
Yeah, hi, Will Reinhardt from Tech Freedom. I wanted to actually ask Michael about this, and the report you put up was, I was trying to figure out what market it was in. Was it in America or the European Union of some sort? Because it looked like it was, or you mentioned it was from...
On the projected levels
Yeah.
of Wi-Fi offload?
Yes, because you put
European
it...
Commission, yeah.
Okay, so from what I understand, I mean, Europe is still kind of undergoing their 4G right now, and I'm wondering if you think that in America, I haven't really seen too many really good projections on how much is offloaded, and it seems to vary pretty drastically depending on which carrier you're at, depending pretty much based on whatever the congestion for that individual carrier, which is then related to how much spectrum they have or they do have in the pipeline. So I'm just wondering if you could talk about that and the substitutability of offloading with regards to, I mean, maybe I'm not being completely articulate in this, but it seems to me that there is this kind of chicken and egg problem here because, let's say a large carrier doesn't have the spectrum, well, then they are limited in their ability to serve their customers. Their customers then go to offload because that is a better service, and to a customer, it's basically just a substitutable service. Wi-Fi doesn't really matter compared to 3G or 4G, just depending on that. So I'm just wondering if you, like what you've seen in America, some good examples of that, and then how if actual carriers got more spectrum themselves, if they would have kind of a different outcome.
Yeah, and I'm sure all three panelists will have view on
Yeah.
that one.
So, okay, so if I'm understanding you correctly, it's definitely a trade-off. I mean, a very good example how this all, Charla was almost, hinting at this, how this got started was, so what, 6 years ago, there was, very little mobile device traffic, and the iPhone came along. And so AT&T had an exclusive the first 2 years, and suddenly said, "Oh my God, now we're, now we're getting overwhelmed." So they acquired Wayport, which was a hotspot company and expanded their hotspots to like 35,000, and it's been, I think, doubling every quarter in terms of the number of users of their hotspots. So they kind of were pushed to take that strategy really quickly. Some other carriers, apparently Verizon, didn't need to as much for a variety of reasons. On the other hand, it's very interesting at the other extreme, and this is where I think the cable, this whole huge cable Wi-Fi build out is really interesting. If you look at what, so I mentioned 10 million hotspots by the phone consortium, so wireline providers building millions, is if you look at the business model of Republic Wireless, which has come along and said, we can give you really cheap mobile service if you don't use our network. So basically they're the one carrier that's saying, please don't use us. We're going to push you onto Wi-Fi. Our software is going to push you onto Wi-Fi everywhere possible, but as a backup, when you're on the go, they're a Sprint MVNO, a virtual operator over Sprint. And so for $19.99 or something, you get just a limited number of minutes and texts and data. Very limited because it's only meant to be used when you can't be on Wi-Fi. And so it's going to be kind of interesting down the road if you see some of these, and it'll probably happen, well, it's already happening with Free, right? I mentioned that Free Mobile in France, because they built their mobile service on top of Iliad's wireline network, they're pushing their mobile customers onto their own wireline, and so they're able to price much cheaper. So again, it's just the trade-off between, are you rich in spectrum, are you rich in wires, what's your business model?
And Charla, Preston?
Well, actually, I had a question for Preston, so let's see if,
I think there's another way to measure that behavior. Notice how many tablets are sold without cellular, 3G, 4G. And so very clearly, people are finding that reliance on unlicensed alone is an adequate contact carrier. You can't imagine a tablet without Wi-Fi, but yet I think 80, perhaps very high numbers are sold without carrier. And I think that's sort of telling us that we need to do a lot more work to make these services integrated, because people shouldn't be buying without it, because we partition this world. So who does it? And when you'll know you've achieved what you talked about, and I don't think you will, when you see in Google Android it leaves this little box that says don't download unless you're on Wi-Fi. And I don't know about Surface, you probably have the same thing. And so right now people clearly don't view them as equal. I think we've got a long way to go.
Well, actually, just to mention one thing that I don't know whether people are aware, we've not said anything about this, but AT&T has said that they're going to put Wi-Fi in all their small cells. So think about that. That's, creates kind of an interesting thing. But since I got the floor, can I ask Preston a question?
Sure, no.
We also have a couple of questions still in the audience
Okay.
too.
Well, this is actually one that I thought would help people understand.
Yeah, go ahead.
So, you were talking about, a lot of us talk about unlicensed and we think about Wi-Fi. But unlicensed isn't just Wi-Fi, and I think you were actually alluding to that. Some, new forms and some things that could be coming down the pipe that actually may allow for a much more sophisticated sort of consumer experience with Wi-Fi-like premises. And I was just wondering if you could elaborate a little bit on that.
I personally think that LTE has a lot of advantages for the consumer. I would rather have an LTE access point in my house than a Wi-Fi one. I think the security features, the integration with the carrier products. Click on. I believe there's a lot of advantages to LTE. The reason we can't do it is we can't deploy independent infrastructure, and the cost points are very high. So I think one of the home runs of having a band that has both of these devices in is that we get the very large ecosystem of Wi-Fi, hundreds of millions of access points sold, together with a lot of the technology that's in LTE. Cisco's Hotspot 2.0 is kind of bringing Wi-Fi towards LTE. Other people, LTE-A and all, are bringing LTE down. And ultimately, one could imagine these coexist where you would have LTE and Wi-Fi. The metric we should be using for spectrum is Netflix streams per megahertz. That's really the metric. It's not bits per hertz. It's Netflix streams. And in that case, you might find that LTE is a pretty good product. And being able to at least make them compete in the exact same marketplace, in the same place, in the same spectrum, has to be good for everybody in this room if you care about the internet.
Since we don't have as much time left, we'll take a couple of questions at a time, so that way they can get answered. I also had a question. It's Judith Hellstein from the board member, council member of the isoc-dc chapter. You mentioned Ron Carlson when you first started up in your remarks, and he talks about an efficient market, but sometimes an efficient market will not lead us to a competitive market with enough competitors. And so I just wanted to ask the panel about that, because it's a different question. Is like the most efficient use of the spectrum will lead the incumbent operators to be able to make the best use out of it, as opposed to the other players who are smaller. So that's a question I want to pose to the audience, and then we have some more questions over here.
Very quickly, Roger Cochetti. I work with companies in the e-commerce sector, and one topic that comes into public view periodically and then kind of fades is the spectrum allocation for mobile satellite communications. During the 80s and 90s, a substantial amount of desirable spectrum was allocated for this purpose. And then in the 2000s, there was an effort to sort of repurpose mobile satellite spectrum to some extent. Could any or all of the panelists clarify what's the utilization level of mobile satellite spectrum, and what is the outlook for its use or repurposing, whatever the case may be? Thanks.
You guys seem to be looking at me. I'm not sure, clearly it's not on the level, mobile satellite, on the level of the 300 million plus customers of terrestrial mobile, but no, I'm actually not good. But in some ways, I don't think it was ever meant to be that. It was, clearly, rural areas where you couldn't get to. I mean, there's still, we cover, 95+% of the population of the United States. And there's still significant areas of the U.S. that, you have like one person per square mile or fewer. So I think that's really in some ways the real benefit of MSS. What's interesting is over time, a lot of them have found that the business case is difficult to meet without having some sort of terrestrial component in their spectrum. And I think that's what you've been seeing is, move toward allowing extra flexibility. There are probably other people even in the audience who might be able to answer the question better than I can, but my sense is that the FCC is still very strongly supportive of having, strong MSS, and there still are, some very good providers. But the question has become over time whether too much of that spectrum was actually, allocated for that purpose. And they've made decisions over the last 10 years to sort of cut back on that. The difficulty is those allocations are made internationally. Mm-hmm. And so, in fact, a lot of people don't even realize that the original PCS 20 years ago took a sliver of MSS spectrum away from the international allocation. So we've been doing it for years. And I suspect, I think there always will be an MSS, industry, but I think more and more of them are trying to tie it in with the terrestrial component in order to just, make it work. So I don't know if anybody else has.
Yeah, and the MSS, I think it's worth mentioning that actually, so I think everybody's familiar, the National Broadband Plan had suggested, or recommended you needed 500 megahertz more was the initial goal. And actually, mobile satellite spectrum has been the largest component of what's been repurposed for cellular use, for terrestrial flexible use, about 90 megahertz. Unfortunately, a lot of that is not usable at the moment. It's sort of three parts. The spectrum that went to light squared, which is currently not usable because of objections from GPS, which go back to what Preston said about, here were guys who had basically free access to spectrum, and so they built wide open receivers because, which can't stand having a neighbor. So light squared is hobbled. But the spectrum that is going to be used apparently very well is by Dish. Dish Network acquired out of bankruptcy of two companies, 40 megahertz, and Globalstar has also MSS spectrum, which is being combined. It's about to be released by the commission, combining it with the top 10 megahertz of the unlicensed band at 2.4 to create a sort of fourth proprietary Wi-Fi channel that they'll lease out for small cell. So in any event, basically the bottom line is most of the mobile satellite companies went bankrupt. Inmarsat is still doing great, but that spectrum is going to be much better used with the terrestrial component.
We have time for 2 more questions.
So I think we're at time, right? So, and did you want to?
We're good. We started a few minutes late, so we can do an extra question.
5 minutes to wrap up.
Okay. So then we'll have the last.
Let's take one question and then
Yeah,
give a
this
couple
is
minutes to wrap up.
related.
Maybe yourself, we'll run some. Yeah.
Morgan Reed with ACT. Quick question for Charla. It's interesting, we've been talking about shoving stuff off on a Wi-Fi or LTE. I love LTE, I agree with you on that. But could you talk a little bit about if we don't provide enough spectrum for you to be able to monetize, how do we take care of the middle mile? Because I'm already starting to worry about middle mile funding, getting the rights of way, getting the ability to pull the fiber. So you might have it great to your home, but if it's constrained, if there are too many Netflix, as you said, being downloaded from the Wi-Fi access, somebody's got to pay for digging up the roads and putting up the microwaves so that we get effective middle mile. When we talk about your build out, how much of your build out actually goes to making the complete system function, not just the tower?
Yeah, and actually, you raise a really important issue, and I'm not even sure I have an answer to that, because I do think, one of the things that, in fact, we're looking at with respect to small cells is how to actually get it out of, this is so off topic in a way for this group, but things like historic preservation that make it very difficult for you to actually build, a full tower site, whether or not those rules should apply to the small cells, but all of the types of things that you're talking about, bringing fiber, as far as you can possibly bring it, into the cell site, further into small cells, are, critical issues. I mean, we actually, but it's also incredibly costly to do some of those things. And, I'm not really sure I've got an answer other than we're working all the issues and kind of keeping, we're talking about spectrum, but we've got a lot of people who are actually working on exactly the kinds of issues you're talking about to make sure that we can even deploy.
And that's one reason that, it was part of what I point out was probably glossing too quickly over with talking about Wi-Fi offload, but that's one reason that you're seeing the capacity for mobile device traffic move to the edge of the network, where people have already provisioned the wireline backhaul. So you already have wireline backhaul in your home, probably your office, I'm sure it has even fatter pipe. So it's already there. And that's why you're seeing a majority of traffic, move over this, a short distance, through the air, a short distance over shared spectrum into the wireline that's already provisioned for other purposes. So it's piggybacking existing infrastructure. It's edge network economics for small cells, which is much more efficient. It's really difficult for carriers to be building the, pushing their infrastructure down your street and close to your home. And that's a reason too that there's all these projections of the enormous cost savings for carriers in terms of the total experience of their consumer, because they won't have to use the carrier infrastructure or the carrier frequencies most of the time if we have ubiquitous wireline.
And actually, unless you have anything. Okay, so actually I think that's a great place to end because, and one of the reasons is middle mile could be an entire panel in and of itself. Wi-Fi offload could be another panel in and of itself. These could be separate events that the Internet Society could host. But those are, it shows that these issues are not, spectrum is only one of the many issues that that faces this industry. So with that, thank you for your time. Thank you to the panel.